Okay, let's look at this next problem. They're giving us a function that's twice differentiable, which means both the first and the second derivatives exist. And we're trying to find both the value, so either positive, negative, or zero for the first derivative and the second derivative. So I'm going to make a little chart. Okay, it's not my best chart, but it's kind of hard to draw with this pen. You guys don't even know. All right, anyway, so let's look at this point P, and we're asked to classify whether it's positive, negative, zero for the first derivative. So you're thinking about, here you should be thinking about slope, and second derivative, we should be thinking about concavity. Okay, so I look at this point, and to me, I see the function is decreasing. So I know that the first derivative is negative. I also see that it's curving up. So it's concave up, so that's telling me that this is positive. Okay, that's all we're doing for this whole chart. So let's look at point Q. Point Q, the function is certainly increasing, so that's going to be positive. But what about the concavity? Well, looks to me like this function is concave up to here, but then suddenly over here I'd say it's concave down. So to me, this looks like a change in concavity, right? At this very instant, there is no curvature. The function is not curving up or curving down. It's changing concavity. So I would say it's 0 there. For R, still increasing, so positive, and as I just said, concave down, so that one's going to be negative. And for S, now we're no longer increasing or decreasing. We're at this local maximum, so we know that at the local maximum, that derivative is going to be 0. And the concavity, well, it's concave down, right? So that is still negative, second derivative. And finally, for T, we're decreasing, so the slope is negative, and also concave down, so also negative.